Good morning, everybody. This morning, I want to start talking about theory that is prevalent in motor learning. Over the last several years, we have tested the cognitive basis related to motor learning. In the last few weeks, you and I have examined dynamic systems approaches as a theory to explain motor learning. Today we're going to start to look at Schmidt's schema theory that he offered to us in 1975 and that is published in the journal Psych Review. You'll see this theory as we move along in the slide set today. But before we actually begin talking about Schmidt's theory, I want to remind you of what theory is. Essentially, what a theorist does, or what a theorist is known for, is having a very large scope of the literature and what the literature says. The good scholar theorist is able to take the literature and actually interpret it and then integrate it in ways that haven't been examined before. In other words, how does the empiricism, the empirical work that's published in the literature, how does that contribute to the understanding of phenomena, large-scale things? In the case of Schmidt, he was looking at the understanding of the cognitive presence or the cognitive processes that underlie motor performance. So I want to remind you of Adams' model that we discussed in the last unit. Adams proposed his model in 1971. He called it a closed-loop theory of motor learning. I want you to notice in this closed loop theory that the memory trace is where it all begins. That is basically the stored cognitive representation of what the performer intends to do. You have a motor program that oversees what the performer is doing, that leads to output. That's what we see in the environment. And when we move, we get proprioceptive feedback, and thus becomes the perceptual trace. And notice that I've put these up and down arrows in our model because it is the comparison of the memory trace to the perceptual trace that allows us to detect errors. In other words, if the proprioception doesn't match what I intended to do as in the memory trace, then I know that I have an error in my movement and I may want to correct for that error. It's possible that the error still allows me to have good performance. So notice I ask you a question here. Can you tell me what this arrow represents? Going from output back into the system. In other words, what is the perceptual trace? I would say that the perceptual trace is related to the proprioception that an individual receives following output, the movement, and then making this comparison back to what we intended to do. And here's your absolute judgment paradigm. You have a memory, and you're comparing something that you're feeling right now to that memory. So Schmidt actually had some criticisms of the model presented by Adams. In other words, he said that A trace theory, or argued that a trace theory that requires very specific representations of each movement that we do, including all of its variations of movement. So in other words, where where might all of these traces be stored? And the second issue that Schmidt criticized Adams' model for was something called novelty. In our daily lives, we deal with novelty because everything we do is with great variation, and certainly we're confronted with novelty at many times during the day. For example, every time I walk across campus, not only might I take a different route, which represents novelty or newness, but also I encounter different obstacles, such as people, such as those carts that are moving across campus and so forth, people on skateboards, and it used to be on electric scooters and so forth. Also, a criticism of previous models is altogether the hierarchical representation of a motor program to guide motor behavior. This is not Schmidt's argument with Adams, as you'll see in the next few slides. Schmidt continues to argue for a program to guide motor behavior that is unlike what we see in dynamic systems models, where this criticism emerges from. So what is Schmidt's schema theory presented in 1975? Basically, Schmidt is proposing the presence of a schema representation. A schema is a generalized representation of something. Remember that Schmidt's argument with criticism of Adams' model was, where would all of these things be stored if in fact we had to have specific traces of our movements and every variation thereof. With regard to schema, rather what we have is a generalized, stored abstraction or representation. Abstraction means that it's not stored necessarily for its exact value, but rather it's stored based upon certain information that's important to that representation. Also, Schmidt argues that the motor program is more generalized, and that with each variation that I experience with regard to the motor program, I'm able to attach very specific parameters and therefore use that motor program to govern a specific situation, like walking across campus and encountering a cart or a motorized vehicle. So I want you to notice my analogy of the cloud here. You saw it on the last slide, and now you see it on this slide here with regard to the boundaries of the schema. The schema is flexible. It has plasticity. Same thing. In other words, you look at this schema, and if you would imagine that this represents the schema in your brain, it's more of a cloud formation with depth and breadth. It also has depth this way from front to back, and this way we are able to create deep and broad schema. It's not so specific as Adams' model would be. It would be certainly a point, but rather not have this plasticity as discussed by Schmidt. Also, people in the dynamic systems camp would argue that by changing the initial conditions of a particular movement, this would also require the placement of parameters onto the schema, though a dynamic systems specialist would not buy this hierarchical representation of the schema. So, to complete our lecture for today, I want to talk about 4 things that Schmidt argues surrounds the schema formation. In our lecture today, I've used a few times the word argue. When I'm using that term, it's more about how a theoretician sets up the underlying assumptions and critical definitions for what he or she is proposing. So, according to Schmidt, 4 things are stored with regard to the schema. The first is referred to as the initial conditions. We studied the initial conditions in dynamic systems, understanding that that changes the nature of how the parameters will be attached to the movement. The response specifications, or the motor program commands. In other words, how fast is the arm going to move? How much force will the arm put in, or the hand put into the ball? All of this relates to the exact motor program commands. In addition to that, the sensory consequences of the response produced. We've talked about that in Adam's model. He called that the output. We've called it the movement itself, or the motor pattern is what describes the movement output. Well, once you do have movement, you have a set of sensory consequences that are associated with that movement. And that would be the sensory consequences of the response-produced feedback. That would be the proprioception we've talked about. And then finally, what is the actual outcome of the movement? Did you achieve the goal? Did you not achieve the goal? According to Schmidt, the generalized motor program that we talked about in terms of what is stored resides in what's called the recall schema. The recall schema is associated with the motor the motor plan, whereas the response-produced feedback, which would be the proprioception that we've talked about, resides in the recognition schema. In a couple of slides ago, we talked about Adam's model, and he refers to a memory trace and a perceptual trace. Schmidt is now referring to a recall schema and a recognition schema. The recall schema is stored representation, a generalized abstraction, because it's a schema represented in memory, and it actually guides the movement. Whereas once you have output, that has feedback. That feedback is proprioception, the response-produced feedback. That feedback resides in what's called the recognition schema. On Thursday in class, we'll take a closer look at schema theory and how these things are actually developed. I look forward to seeing you then. Bye.